responses occur, just the detection. So then, what I'm using this for is I have a grid where I know the exact center position of each one of these elements within my grid. So let me restart this and move up here. So I'm in the corner, get on one of them. So my player is currently over this red one. I know the position of the red one. So when I need to spawn a player, and we'll look at the code later, I'm just telling you in a nutshell. So in a nutshell, what I do is every time I need to spawn an enemy, I look through all the grids and I say, have you been marked as okay to spawn? Basically, when the player is over and it's red, it's been marked as not okay to spawn. But every place else that is green is okay to spawn. So what I'll get is 15 grids where it's okay to spawn and 1 grid where it's not. And then I will randomly select one. So in this case, it randomly selected this yellow one. It found that all these 15 green ones were okay. It selected this one randomly and said, that's where I'm going to spawn an enemy. And then what it does is it says, where's your left side? Where's your right side? Where's your top? Where's your bottom? I will spawn an enemy somewhere within that little tiny boundary. So it takes the whole game board, finds a place where it's legal. Basically, don't spawn it right on top of the player, but spawn it nearby, perhaps, and then spawn within the bounds. So this is a very simple technique to create a spawning mechanism for your games. And the beauty of this, to me, is that you can further refine this by creating smaller and smaller grids. And then you can start to introduce rules. Like you could say, okay, all of these are okay to spawn, but really what I want to do is it's a high difficulty level in my game. And I'll say, choose just the grids that are near to the player. So these are all legal, but I just want you to look at the whole list and go, is it near to the player, within a certain distance? And now refine my pool of okay spawning points to that, and then randomly select one. So what you're doing at that point is you're saying, now I could spawn anywhere, but I'm only going to spawn as close as possible, but not quite on top of my player. Or one thing that they do in the game that I really admire is that let me start this game up again with several enemies, and you'll see that there's a technique you can use with the current game as it is defined. You can sit in a corner, and then you're pretty good, because I know that they're not going to spawn here. And now, I have a visual representation, but when the player is playing this, they will eventually discover this concept that no enemies spawn in the very near vicinity. And they'll think, I'll just sit in a corner, I'll be good. Well, the original game that we're cloning is not stupid. They identify that you're in a corner, and they track the fact that you haven't moved for a while, and they will spawn enemies back here. They'll give you a little visual warning. You see how these pop in and they don't start moving right away? At that point, they're no danger to you. But as soon as they start moving, you got to get out of the way. And so what they do is they'll start spawning a bunch of these guys right behind you to keep you from playing this little technique.
Almost penalized.
Okay, so we've talked an overview, and I got a chance to sort of talk about some of the cool things that are coming up. Why don't we talk now specifically about a topic that we can package up as a topic for today's learning. And actually, before I go on to that, I do want to give you, Charles, the opportunity to sort of select where we're going here. Now, what I want to talk about today is reusing code. So it's kind of a pseudo-boring topic, but I really need to talk about it first to get people on board with how this game is developed. But before I do that, there's one other option. If we want to stop at this point, and I know this is kind of weird. This is kind of weird because I'm used to talking just through, and then you've got sort of like the job at the end of the day to go, how do I cut that up? But now that we're really thinking about cutting this up, if you want to stop on the topic, the game development today entirely, we could talk about another standalone topic called shuffle bags, which I made as sort of like a just-in-case emergency topic for last time. And shuffle bags is a way to get a well-distributed random set of data. For like if you're making a card game or something, you need to have a deck of cards with exactly 52 cards and specific cards, and you don't want to get repeats. Shuffle bags is the way to go. So, do you want to stop talking about the game, or do you want me to go ahead and just start the reusing code segment, which is sort of a dry starter for this one.
Okay, can you hear me all right here?
I can hear you. I can't see it too well, but I can hear you.
Yeah, I don't know. Something's running crazy in the background here. So, well, what do we have beyond this sort of overview piece? I mean, if we go into the next piece, what's ahead of us for this
So
game?
what this next part is the very starting point that I'd like to talk about is how I've taken some of the code from the last game, and then I want to encourage people to use some code out of SSK, and I'm going to show it to them and give them an understanding of why we're using that code. So usually I don't use SSK, but there are some parts of that library I just can't live without, and I really want to encourage people to use them. They won't interfere with normal development. They'll only help you.
Okay, and so my next question would be, can we fit that in the next 20 minutes, or is that something we should
Yeah,
just,
we can certainly fit that. That would be a perfect fit for the next 20 minutes.
Okay, well then let's do that, because I think at this point people want to see code. We've kind of got an overview of the game and some of the intricacies, so let's see some code.
Okay, let me shut her down here, and let's just get this up here so you can see what's going on. Shuffle bag be gone. And let's go ahead and bring up the whole thing here. So, first of all, Geometry Wars Clone has a docs folder and an app folder. Within the app folder will be a game folder. Yes, ignore the fact that there's a copy. I do that when I'm working. And it has the same structure as it always has. Now, this is the way I've been operating for a while. What I do is I start off with our last game. I basically copy it over into a new directory. I cut out all the bits that I know I'm not going to use. I comment out the bits that I don't want to run initially, and then I start coding. So this time around, it's going to have the same folders as previously. It's going to have scripts, a sounds folder. It'll be temporarily containing the SSK folder. However, the topic that I want to talk about today is I've been flip-flopping a little bit about should we use SSK, should we not use SSK. Last time we did a game, I said we're not going to use it. I'm going to try to keep this as pure as possible. So when I say pure, what I mean is it doesn't have any of the advanced features that come from SSK. So I use just Corona function calls, like display new rect, native new text. I don't use any of the fancy ones out of my library because I don't want people to say, I don't understand, where's the documentation on that? I don't understand. I don't see that in the code, or I don't find that on the website. But when I do that, one of the frustrations for me is that there are things that I put into SSK that just make my life so much easier that I'm always on the fence. I'm like, okay, how do I get that in there? Last time around, I put some of that stuff in common. So common is our sort of like dumping ground for things that we want to be both globally visible and generally available throughout the game. This time around I said, that's it. I'm just not going to do that again. So what I have done is I have reused components of SSK, but just those that do not interfere with traditional programming. And you're going to find those in the SSK core folder. And basically, the only two things that I have added that I will be using throughout the code are my globals, which is both global variables and global functions that I use continuously, and then extensions. And extensions, well, they're both equally important, but I think extensions are the ones that people will really be able to sort of dig into. And what I've done is I've added additional functionality to the display class, to the display library, the IO library, the math library, string, table, and then I borrowed somebody's code to extend transitions to also handle color transitions. So just to stop for a moment, one of the things that you can't normally do with transitions is change the color of an object. Normally transitions can change just one field. But somebody out there wrote a clever bit of code that allowed you to transition the color of, say, a square from red to green, which is really a cool idea. Having said that, let's take a quick look at, let me bring up the proper, where is it? View, project file tree. Let's take a look at some of the stuff that I am reusing from SSK, the SSK core. 100%.